In the spring of 1997, the most advanced weather prediction system in the United States, 62 surface stations, satellite imaging, supercomputers forecast that the Red River would crest at 49 feet. A 72-year-old farmer in Minnesota read a handwritten journal her grandfather had started in 1891 and said the number was wrong. She said 54 feet. She warned her neighbors. She moved her own equipment to high ground. The director of NOAA's Regional Forecast Center called her methodology folklore. 3 weeks later, the river crested at 54.35 feet, the worst flood in North Dakota history. The supercomputers missed it. One old journal didn't. What did she see that they couldn't? The first entry in Ingrid Holmberg's weather journal was dated the 3rd of April, 1891. It was written in Swedish, in the careful, compressed handwriting of a man who had learned to read in a one-room schoolhouse in Dalarna province and had never entirely lost the angular economy of that education. The ink was purple iron gall ink, the kind mixed from oak galls and ferrous sulfate that he had brought from Sweden in a small ceramic bottle, because he did not yet know where to buy it in Minnesota. The entry read, translated, "Arrived Stearns County. Sky clear. Wind from northwest. Strong. Ground frozen hard under 6 inches of old snow. Temperature at dawn approximately -18 degrees. Planted nothing. Observed everything." He had come from Sweden at the age of 31, with a wife named Britta, 2 children, a trunk of tools, and a conviction formed during the disastrous winter of 1,887 inches Dalarna, when late frosts had destroyed 3 consecutive harvests, that a man who did not watch the sky with discipline would eventually be destroyed by it. He had seen what weather could do when a farmer was not paying attention. He intended to pay attention. He bought 160 acres of black soil farmland in Stearns County and built a house. In the first year, he built 3 things: the house, a root cellar, and a wooden instrument shelter on a post in the yard, a louvered box, open to airflow, that contained a thermometer, a barometer, and a rain gauge. He recorded the readings every morning at 6 and every evening at 6. Without exception, he recorded cloud cover, wind direction and speed, the first and last frost dates, the depth and duration of snow cover, the date the ground froze hard in autumn, and the date it thawed in spring. He wrote on the first page of his first journal, in 1891, "The sky does not care about our theories. Write down what you see, not what you think. After 50 years, what you have seen will teach you what you have never thought of." Ingrid Holmberg kept his weather journal for 44 years, until his death in 1935. His son Eric kept it for 31 years, until 1966. His granddaughter Ingrid, born in 1925, the year Gustav recorded the driest summer in his 44 years of observation, had kept it since 1967, first with her grandfather's louvered instrument shelter and later with a newer thermometer, a replacement barometer, and the same rain gauge, repaired 3 times, that Gustav had installed in 1891. By the winter of 1997, the Holmberg Weather Journal was 106 years old and consisted of 47 volumes each, a hardcover composition book, filled front to back with daily entries stored in chronological order in a cedar cabinet in Ingrid's farmhouse kitchen. The earliest volumes, Gustav's originals, had purple ink and Swedish text. Eric's volumes had black ink and a mixture of Swedish and English. Ingrid's volumes were in English, blue ink, the handwriting rounder and more spacious than her grandfather's but no less precise. 106 years. 38,690 consecutive days of weather observation, recorded without interruption through 2 world wars, the Great Depression, the Dust Bowl, and 8 United States presidents. Dr. Stephen Quarles, director of the NOAA North Central Regional Climate Prediction Center in Minneapolis, had seen a summary of the Holmberg Journal collection once, in a regional agricultural newsletter. He had described it, in a faculty meeting at the University of Minnesota, where he was also an adjunct professor, as an interesting piece of local folklore, but not scientifically rigorous data. He had then returned to discussing the numerical weather prediction models running on the new DEC Alpha workstation that his center had installed the previous year. That was in October 1996. By March 1997, he would have reason to reconsider. Ingrid Holmberg was 72 years old and had lived on the same 160 acres her entire life. She was tall, spare, with white hair cut practically short and hands that were weathered but precise, the hands of a woman who had spent 70 years outdoors, doing things that required accuracy. She had never married. She had studied meteorology for 2 years at the University of Minnesota in the early 1940s, before returning to the farm to help her father after her mother died. She had the education to understand the professional literature. She had the data to disagree with it. She spent the first week of February 1997 doing something she did every unusual winter, going back through the journals. The winter of 1996-97 had been exceptional by any measure. November had brought record snowfall to the upper Midwest, 22 inches in Stearns County alone, compared to a November average of 7. December had added another 18 inches. January 1997 had brought a cold so sustained and deep that the ground had frozen to a depth of 4 feet in some locations, the deepest soil freeze Ingrid had recorded since 1936. The snowpack was carrying a water-equivalent content of 3 to 4 inches per foot, roughly double the historical average. She sat at the kitchen table with her current journal open beside her and pulled Gustav's volumes from the cedar cabinet one by one, reading entries from winters that resembled what she was seeing outside her window. She was looking for pattern matches years with similar combinations of deep early snow, deep soil frost, and cold-sustained Januaries. She found 12. She made a table on a sheet of graph paper, columns for each relevant variable: November snowfall, December snowfall, January minimum temperature, soil freeze depth estimate based on thaw date, water equivalent of snowpack, and the spring flood peak on the Sauk River, the local gauge she had been reading since childhood, whose behavior she knew as well as any USGS instrument. 12 winters, 12 springs. The pattern was not subtle. Every winter in her match set, every year with deep early snow, deep soil freeze, and sustained January cold, had produced a spring flood on the Sauk River, between 40 and 60% above the median historical flood level. In years where the soil freeze had been exceptionally deep, 4 feet or more, the excess had been consistently at the upper end of that range. Because deeply frozen soil could not absorb any snowmelt, the water had nowhere to go except directly into the river. She wrote her findings in her current journal, dated the 14th of February 1997. Pattern match: 12 winters. Ichen babai jo shilio, Ichen jo bai ling jo, Ichen jo bai yi shilio, Ichen jo bai ar shur, Ichen jo bai sen shilio, Ichen jo bai sishiyi, Ichen jo bai wu shur, Ichen jo bai leo shirar, Ichen jo bai leo shijo, Ichen jo bai chi shijo, Ichen jo bai basha sen, Ichen jo bai basha jo. All with deep November-December snow accumulation plus sustained January cold-producing soil freeze exceeding 36 inches. All produced spring flood levels 40–60% above median. In the 4 years with estimated soil freeze depth at or above 48 inches, 1,916, 1,936, 1,969, 1,979 flood level exceeded historical record or came within 2 feet of it. Current winter, soil freeze estimated at 48–52 inches. Snowpack water equivalent, 3.8 inches per foot. Forecast, spring flood peak likely to exceed 49 feet at East Grand Forks, possible range 49–54 feet. This exceeds all previous records. She underlined the last sentence twice. Then she wrote, in the margin, "Grandfather's rule, write what you see, not what you think. I am writing what I see." What I see is that 1,997 matches 1,936 more closely than any year in between. She looked out the kitchen window at the snow. In 1936, the Red River had crested at 49 feet at East Grand Forks. It had been the worst flood in living memory. People still talked about it. Ingrid drove to the Stearns County Emergency Management Office on February 18th and spoke to the director, a man named Gary Troost, who was 44 years old, organized, overworked, and deeply respectful of anyone who had been paying careful attention to something for a long time. She laid her graph paper table on his desk and explained the methodology, pattern matching across 106 years of daily weather observation, looking for winters with similar hydrological fingerprints. She explained the soil freeze factor, that deeply frozen ground acted as an impermeable membrane, eliminating all soil infiltration and routing 100% of snowmelt directly into surface water systems. She explained that the 1,997 snowpack water equivalent was the highest she had recorded in 50 years of personally keeping the journal. Gary Troost listened carefully. He asked several good questions. Then he said, "What does NOAA say?" Ingrid said, "NOAA's current outlook shows a peak of approximately 49 feet at East Grand Forks. They've been running their numerical weather prediction models since early February, and you think it'll be higher. I think it will be between 49 and 54 feet, possibly higher if the April warm-up is abrupt rather than gradual." Gary Troost looked at her graph paper. Then he looked at his phone. "I should loop in Dr. Quarles at NOAA before I start moving resources around based on an alternative forecast." Ingrid nodded. She had expected this. "Of course," she said. "But I'd ask you to keep the table. And I'd ask you to look at what happened in 1936. Gary Troost kept the table. The phone call between Gary Troost and Dr. Stephen Quarles took place on February 21st. Gary relayed Ingrid Holmberg's methodology and findings. Dr. Quarles listened without interrupting. When Gary finished, there was a brief silence. "The Holmberg journals," Dr. Quarles said. "I've heard of them. She's been keeping them since 1967. Her grandfather started in 1891. I understand the history," Dr. Quarles said. "The issue is methodological. Pattern matching in historical observational records without statistical rigor is, at best, heuristic. At worst, it's confirmation bias. She's selecting winters that match her prior expectations and deriving a conclusion from a small, potentially non-representative sample. 12 is not a statistically meaningful sample for long-range flood forecasting. All 12 produced above-median floods," Gary said. "Our numerical weather prediction models are running on current observational data from 62 surface stations, 14 upper-air soundings, and satellite-derived soil moisture estimates." Dr. Quarles said, "They incorporate the full physical dynamics of the atmosphere-land system. Mrs. Holmberg's journals, whatever their historical interest, are not a substitute for that." "What's your current peak forecast for East Grand Forks?" 49 feet, Dr. Quarles said. "This will be a significant flood, but the levee system should hold." Gary Troost thanked him and hung up. He kept Ingrid's table in his desk drawer. He could not bring himself to throw it away. March arrived cold and stayed cold. The snowpack deepened. A blizzard on March 8th added another 14 inches to an already extraordinary accumulation. Ingrid updated her journal. March 8. Additional snowfall, 14 inches. Snowpack now at record depth for this date since 1936. Water equivalent estimated 4.1 inches per foot. Ground freeze unchanged, no thaw at any depth. Forecast now points more firmly toward upper range, 52-54 feet. She drove back to Gary Troost's office on March 12th and updated him. He called Dr. Quarles again. Dr. Quarles revised his peak forecast upward to 50 feet, noting that the blizzard had added meaningful uncertainty to the upper bound. It was the first time the word uncertainty had appeared in an official NOAA communication about the 1,997 Red River flood. Ingrid returned home and made a decision. She could not move a county. She could not move a city. But she could move the people she knew. The Holmberg farm sat on the eastern edge of a low-lying corridor that ran from the Sauk River Valley north and west toward the Red River Basin. In a flood year, a real flood year, a 1936 year, the low ground in this corridor could carry water in ways that no modern flood map had ever documented, because the last time it had carried water at that volume was 1936, and the county's floodplain maps had been drawn from data beginning in 1945. Ingrid knew this because Gustav had recorded it. His 1,936 journal entries described water standing in fields that were currently mapped as being well outside the 100-year floodplain. She had 3 neighbors whose low ground concerned her most: the Pedersons, who farmed 200 acres that included a depression Gustav had noted as holding water 3 weeks in 1,936. The Vicklins, whose machine shed sat on ground only 30 inches above the Sauk River's 1,936 high water mark, and the Brobergs, who had a herd of 60 dairy cattle in a barn that would be inaccessible if the county road between their farm and high ground went under. She visited each of them in the last week of March. She brought her journal. She brought Gustav's 1,936 volume. She brought her graph paper table. And she brought a simplicity of explanation that she had learned from 50 years of trying to communicate weather observations to people who were not scientists. She did not talk about water equivalents or soil freeze depths. She talked about 1,936. She said, "Gustav wrote that the water stood 3 feet deep in your lower field for 3 weeks. He wrote it on the 14th of April, 1936. I think we're going to see the 14th of April, 1936 again. I think you should move your cattle and your equipment to high ground before the first week of April." The Pedersons listened and said they would think about it. The Vicklins said they had been farming that ground for 60 years and had never seen water in the machine shed. The Brobergs said, "How sure are you?" Ingrid said, "Sure enough that I've already moved my own equipment." The Brobergs started moving cattle the next morning. April arrived. The temperature rose. The snowmelt began not gradually, as the numerical models had assumed, but abruptly. A warm front from the southwest drove temperatures 20 degrees above average in the first week of April, melting the upper layers of the snowpack faster than the still-frozen soil could absorb any moisture. Water ran across the surface of the ground in continuous sheets, finding every drainage channel, every ditch, every low point, flowing toward the river systems with nothing to slow it. On April 5th, the Red River at Wahpeton was already at flood stage. On April 7th, a late blizzard struck the Red River Basin, adding another foot of snow on top of the melting pack and knocking several NOAA surface observation stations offline. The National Weather Service issued a statement acknowledging that the blizzard had significantly complicated forecast accuracy and that crest projections were under review. Gary Troost read the statement in his office and opened his desk drawer. He looked at Ingrid's graph paper table for a long moment. Then he called the county road department and told them to pre-position sand and equipment at the low-water crossings. On April 14th, Dr. Quarles revised the peak forecast for East Grand Forks upward to 52 feet. He noted that the April blizzard had added unexpectedly large volumes of additional meltwater to the system. He noted that the levee system in Grand Forks had been designed for events up to 52 feet, and that emergency levee augmentation was underway. No evacuation order was issued. The river kept rising. At East Grand Forks, the river crested on April 22nd. It crested at 54 feet and 35 hundredths of an inch, 5.35 feet above the final official forecast, 5.55 feet above the previous record, set in 1897. In the days that followed, Lynn Stouse, the mayor of East Grand Forks, was asked about the NOAA forecast. He said, "They missed it, and they not only missed it, they blew it big." More than 50,000 people were evacuated from Grand Forks and East Grand Forks, the largest evacuation in North Dakota history. Fires broke out in flooded downtown buildings, and the fire department could not reach them because the streets were under 8 feet of water. Grand Forks Air Force Base was inundated. The flood caused an estimated $2 billion in damage. The NOAA post-disaster report, published later that year, identified 5 specific technical failures that had combined to produce the forecast error. Buried in Finding 5 was a precise technical description of the soil freeze problem. The NWS forecast model could not simulate the temporary storage of meltwater that accumulates before conveyances open, meaning that when 3 to 4 feet of frozen soil prevented any ground infiltration, the model had no mechanism to account for it. Every drop of snowmelt went directly to the river. The model had assumed some of it would be absorbed. It was exactly what Ingrid had identified in February from 12 analog winters in a handwritten journal. Ingrid was not in Grand Forks when the river crested. She was on her farm, watching the Sauk River, which peaked on April 19th within 8 inches of the maximum she had predicted. The Pedersons' lower field was underwater for 3 weeks, as Gustav had written in 1936. The Vicklands machine shed took 14 inches of water. They had not moved their equipment, and lost a tractor and a grain auger. The Broberg's 60 dairy cattle were safe on high ground. Their barn remained accessible throughout the flood because they had moved before the county road went under. She wrote in her journal on April 22nd, crest at East Grand Forks, 54.35 feet per radio report. My forecast, 49.54 feet. Soil freeze factor consistent with 1,936 analog, NOAA forecast, 49 feet, revised to 52. Actual, 54.35. The error is consistent with what the 1,936, 1,969, and 1,979 analogs suggested would happen when soil freeze depth exceeds 48 inches. Gustav's principle holds. Write what you see. After enough years, what you have seen will tell you what no formula has yet been written to describe. She closed the journal and put the kettle on. Dr. Stephen Quarles drove to Stearns County on June 3rd, 1997. He did not call ahead. He found Ingrid Holmberg on the porch, reading a technical monograph on historical flood climatology in the upper Midwest. She invited him inside. He spent the first hour looking at the journals. He pulled Gustav's 1,936 volume from the cedar cabinet and read it slowly, carefully, the way an engineer reads a technical document. He took notes. He asked about the instrument shelter, when had it been calibrated, how had the thermometer been replaced, what was the measurement protocol for snow depth. Ingrid answered everything. She showed him the instrument shelter in the yard. She showed him the calibration records. She kept annual comparisons against the official NOAA station in Street Cloud, 40 miles away. The mean annual temperature difference between her records and the Street Cloud station was 0.4 degrees Fahrenheit, a systematic offset consistent with the difference in elevation and regional position. Your calibration records are better than most official cooperative observer stations, Quarles said. Gustav calibrated against the Street Cloud station when he could, Ingrid said. He wrote that an uncalibrated instrument is worse than no instrument, because you trust it and you shouldn't. Quarles looked at his notes. The soil freeze factor, the relationship between deep soil freeze and flood peak exceedance. You found that across 12 analog winters, all 12, Ingrid said. When the ground is frozen below 48 inches, the surface becomes effectively impermeable. Every inch of snowmelt goes directly to surface runoff. The models don't capture that because they parameterize soil moisture rather than soil freeze state. Finding 5 inches, your post-disaster report says exactly that. Quarles was quiet for a moment. You read our post-disaster technical report. I read everything written about the 1997 flood, she said. It is the most important weather event I have observed in my career. He looked around the kitchen at the cedar cabinet full of journals, at the graph paper table still sitting on the counter, at the photograph on the wall of Gustav Holmberg standing in front of his instrument shelter in 1910, looking at the sky with an expression of absolute concentration. "Mrs. Holmberg," he said, "I called your methodology folklore. I want to apologize for that." Ingrid looked at him steadily. "Your objections were scientifically reasonable," she said. "What was wrong was assuming that rigorous data must come from instruments built last year. Gustav's calibration records are in the journals. The measurement protocols are documented. This data is rigorous. It is simply old. I'd like to spend more time here," Quarles said. "I'd like to go through the full analog set. I'd like to build a proper statistical framework around the soil freeze variable." Ingrid considered this for a moment. "You're welcome to come back," she said. "On one condition." "What's that?" "You read Gustav's journals in Swedish. The translations lose precision." Quarles blinked. "I don't speak Swedish." "I know," Ingrid said. "But I do." Quarles returned to Stearns County 7 times between June and September 1997. He brought a graduate student named Melissa Park, who was writing her dissertation on long-range snowmelt flood forecasting in the upper Midwest. Together, they went through all 47 volumes of the Holmberg Journal, systematically extracting the variables that bore on spring flood prediction. November and December, snowfall totals. January minimum temperatures. Estimated soil freeze depths derived from thaw dates. Snowpack water equivalents on March 1st, and spring flood crest heights on the Sauk River gauge. The dataset they assembled covered 106 years, from 1891 to 1997. After careful quality control, it was the longest continuous daily weather record in private hands in the state of Minnesota. Melissa Park's dissertation, completed in 1999, confirmed Ingrid's pattern match with formal statistical rigor. Years with soil freeze depth estimated above 48 inches showed spring flood peaks exceeding the median by 52% on average. The relationship was statistically significant at the 0.001 level. Her modeling suggested that incorporating a soil freeze depth parameter into the NWS snowmelt routing model could reduce forecast error for extreme events by up to 40%. The dissertation won the American Meteorological Society's award for outstanding graduate research in applied climatology. In the acknowledgments, Melissa Park wrote, "This work would not have been possible without Ingrid Holmberg, who maintained a century of weather data with standards of precision that professional meteorologists could only aspire to, and Gustav Holmberg, who began the record in 1891 with the simple instruction, 'Write what you see, not what you think.'" The formal process of digitizing the Holmberg dataset began in 2001, funded by a National Science Foundation grant. Ingrid spent 2 winters in Minneapolis working with graduate students to transcribe, translate, and quality control the data from all 47 volumes, translating not just the words, but the system, the shorthand, the precise vocabulary Gustav had developed over 44 years for phenomena that had no standard meteorological name in 1891. The dataset was incorporated into the University of Minnesota's long-term climate repository in 2003 and integrated into NOAA's operational forecasting baseline for the Red River of the North Basin in 2005. The first time a privately maintained, manually recorded weather dataset had been formally incorporated into the official NOAA data infrastructure for operational forecasting. In the cover letter accompanying the data transfer, Dr. Quarles wrote, "This dataset represents 114 years of continuous daily weather observation maintained by 3 generations of the Holmberg family of Stearns County, Minnesota. The observation standards and calibration records are sufficient for quantitative climatological analysis. The dataset is particularly valuable for its coverage of extreme winter events prior to 1940, a period for which instrumental records in the upper Midwest are sparse. We are grateful to Mrs. Ingrid Holmberg, who maintained this record with exceptional care and made it available to the scientific community. He sent Ingrid a copy of the letter. She filed it in the cedar cabinet, behind Gustav's first journal. Ingrid Holmberg died on the 12th of November 2018. She was 93 years old. She had continued recording weather observations until the previous October, when her eyesight finally made it impossible to read the thermometer with the precision she required. Her last journal entry, written on the 14th of October 2018, read, "First hard frost last night. Soil temperature at 4 inches, 34 degrees. Wind northwest. Light. Sky clear. 127 years and 230 days. Gustav would be pleased." Her estate included the cedar cabinet, all 47 original journals, and a sealed envelope addressed to the Minnesota Historical Society. The envelope contained a handwritten letter asking that the journals be preserved and made accessible to researchers, and a note that read, "Gustav came to Minnesota in 1891 and started writing. He didn't know what he was collecting. He just knew that paying attention was the only reliable defense against being surprised by the world. If someone reads these journals 100 years from now and finds something useful in them, that will be enough." The original Gustav Holmberg Weather Journal, Volume 1, 1891, purple ink, Swedish text, leather cover was placed on permanent display at the Minnesota History Center in St. Paul in 2021. The exhibit label reads, "Gustav Holmberg's Weather Journal, 1891-1935, continued by Eric Holmberg, 1935-1966, and Ingrid Holmberg, 1967-2018. 127 years of uninterrupted daily weather observation." In March 1997, this journal and its successors predicted the Red River flood crest of 54.35 feet, when NOAA's numerical weather prediction models forecast 49 feet. The prediction was based on pattern matching across 106 years of observation, specifically the relationship between deep soil freeze and spring flood magnitude, a factor that existing computational models had not yet incorporated. The dataset was digitized in 2001, 2003, and integrated into NOAA's operational forecasting baseline in 2005. The sky does not care about our theories. Write down what you see, not what you think. After 50 years, what you have seen will teach you what you have never thought of. Gustav Holmberg, April 3, 1898. In Stearns County, the instrument shelter still stands in the yard of the Holmberg farm. The louvered box is the third-generation replacement, built in 1971 to the same specifications Gustav drew up in 1891. The thermometer was last calibrated in 2017. 20 feet away, an automatic weather station now reports to the NOAA Cooperative Observer Network every 15 minutes. In the spring, when the snow begins to melt and the soil is still frozen hard below, and the sky carries that particular quality of light that comes before a Midwest flood. Flat and bright and very clear, the two instruments stand side by side, in the yard. One transmits data in real time to a server farm in Maryland. The other stands silent, its louvered sides weathered to the color of old bone. Gustav Holmberg would have recorded the weather in both. He would have trusted neither entirely, and he would have been right.